A scientist begins with 100 milligrams of a radioactive substance that decays exponentially. After 36 hours, 50 milligrams of the substance remains. How many milligrams will remain after 55 hours? And then we're going to round the answer to 2 decimal places. Well, the formula that we use for a continuous growth or decay is the following. We have A of t, which is equal to A e to the RT. Okay, so we know that the initial amount, or the initial amount of radioactive substance, is 100 milligrams. So the initial amount represents A, and therefore we have A, which is equal to 100. And we know that the fact that there's, after 36 hours, 50 milligrams of the substance remains. So therefore, we can say that A of t is equal to 50. And we also know that after 36 hours, that tells us that t is equal to 36. So what we want to solve for is r, and if we look at r is located in the exponent. So let's go ahead and plug this into the formula in step 1. We know that A of t is 50. We know that A is 100. And we have E. We know that t is 36, and that's 36r. So we want to solve for r. So by doing that, we can divide first everything by 100. And so 50 divided by 100 gives us 1/2. And that's equal to e to the power of 36r. Okay, so now what we can do is we can take the natural log of both sides of the equation. So we can say that we have the natural log of 1/2, which is equal to the natural log of e to the 36r. Okay, and so now this becomes the natural log of 1/2. And so this base is e. When we take the natural log of e that has a base of e, then it's going to equal the exponent, which is 36r. And now we can solve for r by dividing both sides by 36. So r is going to equal the natural log of 1/2 over 36. So let's find that approximation on our calculator. So we're going to take the natural log of 1/2, and then we're going to divide that by 36. Okay, so let me go ahead and copy this number here. Okay, so that means that r is equal to negative 0.01925408883. Which is actually approximately, if we want to round that to the 2 decimal places, that becomes negative 0.02, which means that the exponential function, since it's a negative, decays by, if we want to write that by a percent, it would be by 2%. The decay meaning it takes the place of the negative sign. Okay, so now we want to find how many milligrams will remain after 55 hours. So what we want to be able to find is, we're going to let t equal 55, which means that we're looking for A of 55. So we're going to plug it into the formula for number 1. So we know that we want A of 55. We know lowercase a, which is the initial, is 100. We know that we have E. Now the R, we're going to have to use this number here. Okay, we can't use the rounded number because we got to get an exact answer. So up here, we need to use this entire number for R, and then we're going to multiply it by 55. Okay, so let's take that number, negative 0.01925408883. And then we're going to multiply that by 55. So therefore that is the number here. So we can write that if we want to as our exponent, or we can just say, okay, now we can take 100 and then multiply it by E, and then we're going to put the exponent. And now since this is our answer, sometimes your calculator just hit second answer, and that's going to store this number into the exponent. And so therefore it's going to give us 34.68. So the answer is 34.68 milligrams that will remain after 55 hours.